Today, we're diving deep into the essentials of machine learning. Imagine a world where machines learn just like us. Email filters catch spam, cars drive themselves, and apps predict your needs. This isn't the future, it's happening now. Central to this technology is machine learning. In just 100 pages, Andriy Burkov condenses vital insights into an accessible guide. Whether you're new to the field or a seasoned pro, this book is your launchpad. Let's unpack. So what is it? At its core, machine learning enables computers to learn from data. We feed machines examples, allowing them to discover patterns independently. Think about teaching a child to identify a dog, not through descriptions but through pictures. Let's make it tangible. Suppose you want to predict house prices. You have data on past sales, features like square footage and location. You feed this data to a machine learning model. It identifies patterns, linking space and location to price. Then you present a new house, and it makes a prediction. That's machine learning, learning from past data to inform future predictions. Now, machine learning isn't just one concept. It splits into three major types: supervised, unsupervised, and reinforcement learning. Supervised learning uses labeled data. You tell the model what's what. This is a cat, that's a dog. It learns and generalizes that understanding to new data. Then there's unsupervised learning. Here the model has no labels. It organizes data by finding patterns independently, like sorting a messy drawer without knowing what's inside. Finally, we have reinforcement learning. This method learns by taking actions, receiving rewards or penalties, adapting its strategy over time. Think of game-playing AI learning to win. So how does machine learning actually work? Every model requires 4 key ingredients. First, data is essential. More quality data means a better performing model. Next, features. These are the data points that help the model learn. For predicting house prices, features might include home size or proximity to schools. Third, you need algorithms. These dictate how the model analyzes and processes data. Lastly, evaluation is crucial. You need metrics like accuracy or error rates to gauge the model's performance. Let's look at common algorithms, starting with linear regression. It predicts outcomes by drawing a line through data points. Simple yet powerful for numerical predictions. Next is logistic regression, used for binary classifications like yes-no decisions. It outputs probabilities to guide choices. We also have decision trees. These split data based on conditions. If age 30, go left. If income 50K, go right. Each path leads to a prediction. Then there's k-nearest neighbors, or KNN. It predicts new cases based on similar examples in the training set, a social influence model for data. Support vector machines, or SVMs, find the best dividing line between categories, effectively handling complex data patterns. Lastly, neural networks, inspired by the human brain, consist of layers that process data in deep learning to tackle complex tasks like image and voice recognition. Training your model involves splitting data into training and testing sets. Train on one, test on another to see how well it generalizes. Caution: watch for overfitting, where the model memorizes data too closely. Underfitting happens when the model is too simplistic. Managing bias and variance is key. Bias comes from oversimplification, while variance emerges from sensitivity to noise. You need to find a balance. Hyperparameters are settings that control the model before training, influencing performance. Tuning them is both a science and an art. So how do we measure performance? It depends on the task. For classification, use metrics like accuracy and precision. For regression, consider mean squared error. Let's outline the machine learning workflow. Start by defining your problem. What do you want to predict? Next, collect and clean your data, ensuring it's ready for analysis. Then, choose features that will help solve the problem. Select a model, train it, evaluate it, and adjust accordingly. Deploy it once it performs well. Remember, models degrade over time. Continuous monitoring and updates are necessary. Where is machine learning used? Everywhere. from spam filters to voice assistants, credit scoring, and more. Think Netflix predicting your next binge or AI analyzing X-ray images. The 100-page machine learning book offers a big picture and real details, helping you understand the trade-offs and practical implementation. You don't need advanced degrees to start. Curiosity is your best asset. Begin with the fundamentals, experiment with projects, and embrace mistakes as part of the learning process. So read the book, experiment with algorithms, play with data, and create something extraordinary. Thank you for watching. If you're curious about more, like, subscribe, and comment what you want to explore next. Stay curious, stay clever, and keep learning.